Welcome back to the Deep Dive. Today we're taking you inside one of the most legendary research labs of the 20th century.
That's right. We're talking about the Numa-kin, Dr. Shosaku Numa's lab at Kyoto University back in Japan's Showa era.
Numa was a giant in molecular neurobiology, active really up until his passing in 1992.
Absolutely. His work was fundamental. He and his team were the ones who first nailed down the primary structures of crucial things like neurotransmitter receptors and ion channels.
So basically giving us the molecular blueprint for how parts of the brain actually function.
Exactly. It was groundbreaking stuff. And his lab, well, he became famous, maybe infamous, for churning out Nature papers throughout the 80s and early 90s.
It's interesting. He really burst onto that world stage relatively late, around 1979 when he was already 50.
Yeah, but the impact afterwards was just immense. Now, we need to be clear about how we're approaching this.
Right. We're looking at anecdotal accounts, stories from people who actually work there. And the sources themselves point out that by today's standards, Reiwa-era standards, a lot of this would likely be seen as academic harassment.
Definitely. We're not here to judge it by modern ethics necessarily, but to understand it, to report on the atmosphere as it was described.
Our mission, then, is to really get inside that intense environment. What drove this incredible productivity, this culture defined by Numa's own words, effort is infinite.
Let's start there with infinite effort, because it wasn't just a slogan. It was the lived reality.
A 2:47 expectation. Numa himself set the pace, didn't he? Staying until 2 a.m., sometimes even 5 a.m.
Oh, yeah. He lived it. And that meant everyone was expected to be available. Always. There's this one story. A researcher gets a call. 6 a.m. Sunday morning.
Okay, must be an emergency, right?
Yeah.
Lab fire. Contamination.
Nope. It's Numa just casually asking for PSTI.
PSTI. That's a restriction enzyme, right? Standard tool. He's calling at 6 a.m. on a Sunday for that.
Exactly. It shows how blurred the lines were between work and, well, everything else. Even major holidays weren't off limits.
You mean like New Year's?
Precisely. A staff member worked late on New Year's Eve, took the first off, naturally. Then, on the afternoon of January 2nd, planning to head home, the phone rings.
Let me guess. Numa.
You got it. Asking, it's already the 2nd, when are you coming back to the lab?
Wow. The implication is just brutal. Any time off is slacking off.
It was seen as a lack of passion, a lack of dedication. And Numa even connected this dedication, this tension as he called it, to physical health.
How so?
He claimed he personally never got colds because he maintained constant tension, which he believed made his body secrete ACTH, the stress hormone.
So stress keeps you healthy. That's counterintuitive today.
Well, it fit his worldview. There's an incident where someone was late because they had to go to the hospital for a cold. Numa's reaction.
Let me brace myself.
He told them off, saying, "You should not confuse public and private matters. Illness was a private matter, interrupting the public duty of research."
So being physically present, demonstrating that effort, was paramount. It wasn't just about the experiments.
Absolutely. He confronted one person who was just waiting by the phone for a collaborator's call. Numa told him straight up, "I don't feel any passion from you. I noticed you sometimes didn't come to the lab on Saturdays and Sundays."
It all comes back to that visible, relentless presence, which logically leads to the next point, the demand for absolute rigor during that time.
Zero tolerance. For mistakes, for excuses, for anything less than perfection, really. And he established this from the moment you walked in.
Like that story about the new graduate student.
Yeah, incredible. The student was working with an enzyme that wasn't very stable at room temperature, only active for a few seconds.
Okay, a real technical challenge.
Right. And when the student mentioned this instability as a reason for maybe slower progress, Numa's response wasn't advice. It was, "Why don't you quit graduate school?"
Just like that. Quit.
Just like that. The message was clear. Find a way, or you don't belong. Excuses weren't part of the equation. If there's a problem, infinite effort overcomes it.
And this applied even when technology seemed to offer a shortcut, like with DNA sequencing.
Oh, absolutely. This was the era when sequence analysis software was coming in. But Numa insisted his team manually check every single nucleotide sequence the computer spat out.
Manually. Why?
His reason? Computers make mistakes.
Yeah.
He actually claimed that this painstaking manual double-checking was why his lab's previous papers had 0 errors.
So he's directly linking this intense, almost paranoid methodology to their publication success. No trust, verify everything by hand?
It was about achieving absolute data integrity, which, in cloning complex receptors, it's critical. Mistakes could cost months or years.
That makes sense in a high-stakes environment. What about equipment failures? Things break down in labs.
Not an excuse. There's the famous fraction collector incident. Machine stops overnight. The crucial active fractions are lost.
Okay, frustrating, but it happens. What did Numa say?
He demanded, "Why weren't you watching it?" When the researchers said the machine failed, Numa shot back, "It's natural for a fraction collector to fail. I always check it all night."
He expected someone to literally watch a machine run all night long.
That was the implication. Perpetual vigilance. And he enforced this rhythm. Almost every night around 10 p.m., he'd come down to the lab.
For what?
Daily progress reports. He wanted to know exactly what you did that day, and then he'd set specific, tough goals for the next day. No room to just coast.
It sounds incredibly hierarchical, almost military.
He even used that analogy.
Huh.
Apparently, when a colleague tried to push back even slightly, Numa's response was chilling. He referenced the battlefield.
What did he say?
Something like, "I saw those who defied their superiors' orders on the battlefield. The next moment, their head was gone."
Wow, that's intense. But it raises a question, doesn't it? Science is supposed to be about questioning, challenging assumptions.
Yeah.
How did genuine breakthroughs happen under that kind of rigid authority?
That's the paradox, maybe. The absolute compliance wasn't necessarily about the ideas, perhaps, but about the execution. The elimination of error in the process. The data had to be perfect.
And that perfectionism, that rigor, carried right through to getting the work published.
Absolutely. Which brings us to what the researchers themselves called the publication deathmatch.
The death match. Sounds ominous.
And by all accounts it was. This was the final stage, writing the paper. It meant a 2 to 3 week, one-on-one, intense session between Numa and the lead author.
Went on one for weeks.
Yes, often involving pulling multiple all-nighters in a row, and the feedback was brutal.
How brutal.
Authors were told their English was below middle school level, sometimes even preschool level. Manuscripts apparently got torn up in front of them.
After years of work on the research itself, that must have been crushing.
You'd think so. But Numa's view was that the paper was the final product, the only thing the world sees. And the writing itself had this very peculiar method.
What was that?
He called it English borrowing. Basically, you were forbidden from writing original sentences unless the finding was completely novel and required new phrasing.
So, how did you write?
You had to find established phrases, sentences used in top journals like Nature or Cell, written by native English speakers. And for every phrase you wanted to use, you had to provide Numa with multiple published examples.
So he was constantly asking, where's the example? Show me where this was used before.
Exactly. It was about minimizing any risk of awkward phrasing or grammatical error, using language that was already validated, already accepted by the gatekeepers. Scientific precision applied to prose.
It's like building with pre-approved blocks only.
Kinda, yeah. And the pressure wasn't just on the writing, but the submission. He had this incredibly tight schedule.
For mailing a paper.
Yes, specifically for Nature. To ensure the manuscript arrived in London by Thursday or Friday, making it into that week's review batch, it had to be dropped off at the Osaka Central Post Office by 1 p.m. sharp on Tuesday.
Missing that deadline by an hour meant potentially losing a week's lead on competitors.
That's how he saw it. It was about controlling every variable, maximizing speed and competitive edge, utter logistical control.
And this obsession with perfection extended to figures, illustrations
Oh,
too.
absolutely. The story of the alignment figure is legendary. Numa would check figure dimensions with a ruler.
With a ruler. Seriously.
Seriously. They had this huge, complex figure, B4 size, showing sequence alignments. After all the work, they found one single line was drawn solid when it should have been dashed.
Okay, a small error. Can't they just fix it? White out, maybe?
Normally, yes, but Numa apparently hated correction fluid, forbade it. So the entire massive figure had to be redrawn from scratch.
Oh my God. For one dashed line.
And the story goes, the young secretary who made the mistake was so upset her tears actually smudged the ink, making the redo absolutely necessary anyway.
The unbelievable pressure.
Numa's take on it captured his whole philosophy. A paper is like a painting to a painter. You rewrite until you are satisfied. You must not lose power until the last stroke.
So let's step back. We have this image of immense pressure, infinite effort, brutal critiques, but also incredible success. What was the core philosophy Numa tried to impart beyond just getting papers out?
Well, he really emphasized learning through doing. He'd say things like, knowledge from textbooks is important, but you must actually do experiments to gain living knowledge. It is more important to think while doing experiments.
The less armchair theorizing, more getting your hands dirty.
Exactly. And he pushed people to aim high with their research topics, not just safe bets.
What did he advise there?
He told them, do work that is as important and meaningful as possible. He apparently worried that younger researchers were playing it too safe, choosing projects that were easy to publish but didn't tackle the big questions. He called it poking around in the corners of a heavy box.
He wanted them to try and lift the whole box.
Right. He believed scientists needed to take risks. He even compared it favorably to high-altitude climbing, arguing that, research failure doesn't actually cost a life.
That puts it in perspective. Did he have advice on timing those big, risky projects?
He did. He had this very specific idea. A theme that is too early or too late compared to the flow of the world is not good. Choosing a theme that is half a step early ensures success.
Half a step early. Not too far ahead, but just ahead of the curve.
Precisely. And you can see that in his own work, like the acetylcholine receptor cloning. It was a huge undertaking, right when the techniques became feasible and the field was ready for it. Landed him a Nature cover? Perfect timing.
His career really models that advice. High risk, perfectly timed, massive reward.
It does. And after all that intensity, all that demand, there is one quote that shows maybe a tiny sliver of understanding the human cost.
What's that?
He apparently said, a little alcohol is good. Sometimes you need it to bear the hardships of life.
A rare concession to the pressure, maybe? So, looking back, we see this incredible engine of discovery. The Numa Lab produced foundational work, changed neuroscience. But the anecdotes paint a picture of immense personal sacrifice demanded from everyone involved.
Exactly. And that's the tension, isn't it? Today, we rightly prioritize well-being, ethical treatment, work-life balance. These things are crucial. But Numa's story, however extreme, poses a persistent question about what it takes to achieve truly transformative breakthroughs.
That relentless focus, that demand for absolute precision and unlimited effort on difficult, important problems.
It remains a benchmark, even if the methods are now unacceptable. Tackling the very hardest questions often requires something beyond a standard 9-to-5 commitment.
Numa himself said, the most important thing I want to leave behind is the challenge to attempt something difficult. So, thinking about that, and his idea that effort is infinite, where do you, listening now, draw the line?
How do you balance that necessary drive for excellence, for pushing boundaries in your own field, with the need to maintain a sustainable whole life?
It's the fundamental challenge, perhaps, for anyone aiming high. Where does that infinite effort stop? That's something to think about.